In this lesson we will use the strategies from previous lessons in graphing sine and cosine, but now we're going to graph tan, cotan, secant, and cosecant. This will be covered over 2 days, so we'll go over what part of this we'll do tomorrow. Remember that the coefficient of sine, we'd call this an outside change. That means it's a vertical change, and we're going to multiply all the y values by a. B is inside with the x. It's therefore it's horizontal, and we would divide all the x values by b. We're going to do the inverse of what this says. So it's b times x. We're going to divide all the x's by b. And here we have another inside change. It's horizontal. We're going to do the inverse of subtraction. So we're going to add c to all the x values, and then d would be an outside change that is vertical, and we're going to add d to all the y values. So let's look at tangent and cotangent. And let's just use these x values, and we'll find tangent for each of these. So negative pi over 2 is here, and we know tangent is y over x. So the y value is negative 1, and the x is 0. So we have negative 1 over 0, and that is undefined. So there's going to be an asymptote in the graph there. Here at negative pi over 4, we have this where the x value is 1 and the y value is negative 1. X value is 1, y value negative 1, and we want y over x, so that'll give us negative 1. At 0, we're going to use y over x with a y value of 0, so now we have 0 over 1 is 0. Pi over 4, and that is 1 over 1. Pi over 2, we want y over x. The y value is 1, and the x value is 0, so that's undefined. There'll be an asymptote at negative pi over 2 and pi over 2. At negative pi over 4, we'll go down 1. At 0, we go to 0. Pi over 4, we go to 1. And the graph goes like that. And it also repeats. This is pi. The period is pi. So if we get another pi over here, that would be 3 pi over 2. And that same pattern occurs. And that's why tangent has that shape, because of these points. Okay, pause the video and you try cotangent with but use these points. I use these x values for cotangent. Try that. So it's 0. Cotangent is x over y, and the x value is 1, the y value is 0, and that is undefined. Pi over 4, and that will be 1, 1, so that equals 1, 1 over 1. Pi over 2, we want the x value is 0, y value is 1, and this should be 3 pi over 4. Negative 1, 1, and we want x over y, x over y at pi. X is 0, x is negative 1, y is 0, and that's undefined. Alright, from 0 to pi, there'll be one cycle. There's an asymptote at 0 and an asymptote at pi. And then we'll start at 1. Then at pi over 2, we have a y value of 0, negative 1. And make sure we remember these 3 points, because when we do transformations, we just want to deal with those points like we did with sine and cosine. Just memorize those points, and then over here we'll memorize these points and use those for transformations. Okay, let's look at secant and cosecant. Alright, secant. If we're at 0 degrees and we want to have r over x, the radius is 1 and the x is 1, so r over x is 1. At pi over 2, the radius is 1 and the x is 0, undefined. At pi, we want the radius, and the radius is 1. X is negative 1, so the value is negative 1. 3 pi over 2, radius is 1. X is 0, undefined. And 2 pi, we're back here, and that'll be at 1. So 0, 1. At pi over 2, it's undefined and there's an asymptote. At pi, it's negative 1. 3 pi over 2 is an asymptote. And at 2 pi, it's back up to 1. So it's kind of hard to see what's happening there, but we know that secant is the reciprocal of cosine. So every value in secant is just the reciprocal of a value in cosine. So why don't we look at the graph of cosine. And if the y value of cosine is 1, its reciprocal is 1. That means secant is 1. And that's why we have this point here for secant. As we go down maybe to a half, if we have a y value of a half and we do the reciprocal, you would make a y value of 2. So then we see the graph going like that. When the y value of cosine is 0 and we do the reciprocal of 0, that makes it undefined. And so that creates this shape. So that's secant. And we'll just graph any transformations by first graphing cosine and then just reflecting the graph like that. It has the same period as cosine. Okay, use the same x values to make a graph of cosecant. Pause the video and try that. Cosecant is r over y, and the r value is 1. Y is 0, so that's undefined, and there'll be an asymptote at 0. Pi over 2, r value is 1, radius, y value is 1, so we get a 1, radius 1, y value 0. Radius 1, y value negative 1, and then we're back to that. That's undefined. So we have at 0 an asymptote at 0. At pi, another asymptote. And at 2 pi, an asymptote. Plot these points at pi over 2, we'll go to 1. And at 3 pi over 2, negative 1. This is the reciprocal of sine. So if we look at sine, when there's a fraction, a value less than 1 here, we do the reciprocal of that. Like if it's 1/2, the y value is 1/2, we do the reciprocal, we'd go up to 2. And so that creates a similar shape that we saw with secant. That's cosecant. All right, so remember, it might be helpful to think of it like that. And then we just look at whether it's inside or outside. This is outside, so that's a vertical change. and we're going to multiply the y values by -2. Here we're multiplying by 1/3, so we're going to do the inverse of that to all the x values. If it's an inside change, then it's a horizontal change, and we do the inverse of this. If you divide by 1/3, then you multiply by 3. We can also talk about the period, and this is different from the other trig functions because the period is not 2 pi over b, it's just pi over b, because the parent function has a period of pi. So here the b is 1/3, pi over 1/3 is 3 pi. We know to expect the period of 3 pi. Then we just start with the points from the parent function. We don't have a point here, but it helps us keep track of where the asymptote is. So we have changed the y and a change to the x, so we can do them at the same time. Multiply all the y values by -2. And divide all the x values by 1/3, so we'll multiply by 3. So -3 pi over 2, and we're counting by fourths. Counting by 3/4, and we have 0, 0. And -3 pi over 4 will go to 2, 0, 0. 3 pi over 4 go down to 2. So if this is 3/4, or this is 3/2 and 3/2, so this total distance is 6 pi over 2. So we could just go out here again, that same distance, to draw another cycle. And the asymptotes are at -3 pi over 2, 3 pi over 2, and this is going to be 9 pi over 2. Because we added 6 pi over 2. A question in the book asked for the asymptotes, find all the vertical asymptotes. So this is a little tricky. We're going to find, if we say there's a vertical asymptote here, 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 we're going to add 6, add 6, add 6. If we have -3 pi over 2, 3 pi over 2, 9 pi over 2, 15 pi over 2, these are where the vertical asymptotes occur, so we can just do the vertical asymptotes are going to be at x such that x equals pi over 2 times, and then we just have to do 3 times all the odd numbers. And then we can just have n be an integer. Alright, pause the video and try that one. So we see 2 is an inside change that's horizontal, and we're going to do the inverse of what it's doing to x. So it says 2x, we're going to divide x's by 2, and the period is pi over b. So we know the period will be pi over 2. Cotangent, let's start at 0. And these are the points from the parent function that we drew in the beginning. And all we have to do is divide all the x values by 2. So 0 to pi over 2. And we have an asymptote at 0, an asymptote at pi over 2, starting at 1. We can do another cycle. And then we can look at where are the asymptotes. The asymptotes are at 0, pi over 2, pi. So it's x such that x equals pi, n pi over 2. N is an integer. One more. Pause the video and try that one. So we have a 1/2 times x on the inside. That means we're going to divide all the x's by a half or multiply by 2. We're also going to multiply the y values by -1. For cosecant, we just graph sine and then reflect it. So for sine, these are the points of the parent function. And we're going to change the y value by multiplying by -1. Let's multiply the y values by -1. And we'll divide the x values by half. That means multiply by 2. Okay, and so we're going to go from 0, 0 up to pi, or down to pi negative 1, and then at 2 pi we're at 0, 3 pi we're at 1, 4 pi we're at 0, and make that a dotted line because we're going to reflect it. So that's what that looks like. And we can talk about the asymptotes. The asymptotes are at x such that x is 0, 2 pi, 4 pi. That's just the even integers. So we'll go x is 2n pi, or 2 pi n, where n is an integer. Those are the asymptotes. And we'll stop there.